thing go? Gus, do you see major tectonic plates of the Earth on the screen?
Yes.
Yeah.
Yeah. Okay. Now, so this is just like a roughly the map of the world. And so the Earth's crust, remember Earth has got 3 layers. The outside one, which is the solid one, is called the crust. And then there is a mantle, and there are inner core and outer core, 2 cores inside. So this outer layer is not made up of like a one piece of, like you have eggshell, like there is so there is an eggshell, and underneath is a white, and then there is a yolk. So you can think Earth is similar to that, but it's like only the shell part is solid. The white part of the egg, if we correspond to the Earth, that is kind of partly molten, and the inside of the Earth, which is called the core, which is like the yolk of the egg, that is also like, it's thick, like a partially like molten chocolate, partially solid and partially a little bit liquidy. So, but outside is not like the eggshell, it's like a cracked shell. Like if you boil an egg and then you drop it and it cracks into different, shell cracks into different things. So Earth outside, or the crust, has been broken into different kind of what they call as tectonic plates. And these are the major plates. There are 7 major plates: Australian plate, African plate, South American, North American, Eurasian plate, and Antarctic plate. But there are some minor plates too. Now, if we look at the New Zealand, now over here, this part over here is the Pacific plate, which is kind of shown on this side of the Earth. So that's where the New Zealand is. So New Zealand is at the boundary of the Australian plate and the Pacific plate. And these plates, now these continents, which we look at different, this is the position that we see them now. That wasn't their position if we go back like 2 million years ago. And how do we know that? That these plates are constantly moving. At some places, they're moving towards each other, and at some places, they're moving apart from each other. So, for example, if you look at the say, for example, this South American plate and African plate, that's the boundary between them. Now, if you look at the coastline over here, this coastline and this coastline, that matches. And what it means is that, and if we put them together, they will fit in like the jigsaw puzzle. And what it means is that millions of years ago, they were actually part of one continent. And that's the lesson which will come up a little bit later. And I think that was a lesson on the Friday that you have already done that. And also another thing that they know, that this wasn't the position of the plate millions of years ago. So the types of rocks which are found in this area and the types of rocks which are found in that area, they're very similar. Like if there is a granite here, there's a granite here. That means this was one part. Also some fossils, animal fossils, like some of the land animals, they found their fossils over here and their fossils over here. Now those land animals are extinct, and they could not have traveled from here to there. So how do we find the fossils over here and the fossils of the similar animals over here? That means that these continents were once together, and they have drifted from each other, and that's the breaking point. In other words, what we are saying is that all these plates, at some places, so this is the boundary of a plate. So that's the African plate from here up to there. There is some smaller plate in too, or South American plate is from here. All this one is South American plate. Okay. So what it means is at some places they're moving apart, like over here, they're moving apart. But over here, if we look at the Indian plate, and this is the Eurasian plate. Now, over here, this plate is moving down, Indian plate is moving up towards the north, and they meet somewhere over here. So at certain places, those plates are moving towards each other, like here. At some places, they're moving away from each other, and that movement leaves a certain type of geological features that we will be looking at. Okay, so now if we look at the, New Zealand is over here. Does everyone see that little kind of a map over here, North Island and South Island over here?
Yeah.
Okay, so Pacific plate is on this side, which is shown over here. So what is happening is this Pacific plate is moving to the left. Like this is east, west, north, up, and south. So this one is moving to west. And this plate over here, this is called, because it's an Indian plate and Australian plate together, so this is called Indo-Australian plate. And this plate is moving towards this side, towards right. But again, the movement is slightly different in North Island and South Island. I will come back onto that one. But when we say that plates are moving away from each other, so this is, or plates are moving towards each other. So what we say is, if I come down here, before I move on to that, can I just show you this one too? Now, the scientists, how did they know? Because you don't see any kind of a breakdown between the plates as we have drawn in the map here. Now, so this is the same map of the world, but it is like we have put New Zealand in the center rather than just in the corner over here. So how did scientists know that Earth is divided into many plates? So, these little red dots. So for last 100 of years, about 100 or 150 years, scientists have been keeping record of all the earthquake activities. So all the earthquake activities have been happening here, around the edges of the plate. So there are very little earthquake activities here. That means earthquake can happen, but their epicenters are along here. So all the epicenters of all the earthquakes, they've always been along the plate boundaries over here. So these red dots over here, they're showing the epicenters of the earthquakes, where the major earthquakes have happened. Now these green dots over here, they're showing where most of the volcanic eruptions have happened. So volcanic eruptions, they also happen near the boundary. And that's how scientists knew. And then I told you that, there are fossil features and there is kind of the boundaries of the coastline boundaries match like a jigsaw puzzle. So that is a proof that these continents were once in a different position as compared to what they are now. We are more focused on what is happening in New Zealand. So this one is the Pacific plate, which is moving to the left towards west. Now this Indo-Australian plate, this is moving up. So what can happen is, so this is partially like a different type of thing. So I will come back on this one, but before I go that, I'll talk about the plate boundaries. There are three types of plate boundaries. Now, if plates are moving away from each other, then this is called a divergent boundary. So what happens is, and why do these plates move? Like this is the mental part. Underneath the mental is core, inner core, and outer core. So outer core is very, very hot. Temperature is thousands of degrees, but it's not like same temperature all around the outer core. There are some hot spots. And what those hot spots causes, they call convectional currents. So at certain places, mantle will be hotter as compared to the other places. So over here, hot magma in the mantle that is coming up. And because of this movement, there will be currents which will be like that over here, convectional currents. So those convectional currents will move this plate to the right and this plate to the left, and in between over here, so they will be, what it is doing is breaking the crust. So when there's, and remember, these plates are not like a plates like 1 kilometer, they are like 5 to 15 kilometer thick. They're very thick layers, these crusts. So because of these convectional currents, plates are pushed apart. So when they're pushed apart, the crust becomes thinner and thinner in the middle, and then magma comes out. And if it is in the ocean, so magma will come out. So there will be volcanoes, and there are heaps of volcanoes deep inside the oceans. So this part will raise up because volcanoes are coming, and this part will keep moving over here. And they say that crust moves about 5 centimeter every year. So every year. So this part which comes out, the magma that comes out from here, it solidifies and it makes the new ocean bed. So new ocean bed is being formed over here. So this is called constructive boundary because new seafloor is being formed. So this part goes there, this part goes there, magma is coming out. So when it is like this one in the ocean, there will be like a raised. Remember, above that, there's water. This is all immersed in water. This is happening inside the ocean. So, so there will be a ridge here. Okay, so what happens at the divergent boundary is there will be what we call as mid-ocean ridges, because this happening in the ocean and there's a ridge like a raised kind of a mountain ranges, and the new magma will keep coming and these two plates will keep moving further apart. If this thing happens underneath the continent, not in the ocean, then what they create is they create rift valleys. So rift valleys in African continent is quite visible. Okay, so these are divergent plates. Convergent plates are when plates are moving towards each other. Now, what can happen is when two plates are moving towards each other, and remember, convectional currents in the mantle, they're moving them towards each other. So now these are thick layers of 5 to 30 kilometers thick. So either both of them can go up, or they can, one can submerge inside. This crust is different under the oceans and under continents. So under continents, so this one over here, this is continental crust. So this one is lighter. The oceanic crust which is underneath the oceans, that is much more denser. So when these plates move towards each other, if one is denser and one is lighter, so denser will kind of dip down into the mantle, and the lighter ones will slide on the top. So here, what is happening is that crust is going into the mantle, and that keeps happening, 5 centimeters every year. And this one is moving on the top. And because of this one, because these are plates which are like 30 kilometers thick, just colliding together, so you can imagine what can happen. So whenever they move a little bit, there will be an earthquake there. And because of the heat produced when they rub against each other, there will be a lot of volcanoes which will be generated over here. So there will be a lot of volcanoes along the boundary over here. So if we come back on the New Zealand is formed. So this plate is Pacific plate. This plate over here is Indo-Australian plate. And somehow this Pacific plate is denser, so it sinks down. And this plate, which is the Indo-Australian plate, it moves up, but not exactly in this direction. It moves slightly up. So there are 2 or 3 things that can happen in a convergent boundary when plates move towards each other. One is that when this one goes deep inside, it will make, so it will make what we call as a trench, because this is trying to fold inside. So this one will fold. So over here, there will be deep ocean trench. So that means above here, there's an ocean. So in this part, and this, there will be ocean, so like ocean has got certain depth at certain places, but in the trenches, they are so deep that no one has even measured how deep those ocean trenches are. That's the deepest part of the ocean. Okay. Another thing that can happen is if they have similar density, then both of them will move up. And that's what happens where the Indian plate and the Eurasian plate, they meet. I will go back on the main map and show you that one. So that's another thing that can happen. Third thing that can happen is that plates move sideways. One is moving there and one is moving there, and that's called transform boundaries. So they're not putting that much pressure, but nonetheless, they're creating a fault, a crack. And St. Andreas Fault in San Francisco side, that is because over there the boundaries are transform boundaries. One is moving that way, one is moving that way. So these are the three types of boundaries. I will go back over here on the main map that we had over there. So now if you see over there, okay, now, so we are more concerned about so what is happening is in the North Island, this plate is, Pacific plate is moving to the left. This plate is kind of, it's going up, but this plate is sinking underneath. And when it sinks underneath, it creates a lot of kind of heat and pressure. So that's why in New Zealand, there have been so many volcanic cones that you see, like in Taupo, and there have been so many volcanoes. There have been kind of some eruptions and activity from time to time. In Auckland, you see so many volcanic cones, so they are dormant, but you never know at what time they can erupt. Or so this one over here, that's where there's lots of volcanic activity, earthquake activities that have happened in the past, in North Island. South Island is different. Okay. This plate is not sinking underneath. It's moving towards here, and this one is moving up, but they're bulging together. So both of them are moving up. And when they move up, so they make high mountain ranges. So in South Island, we have high mountain ranges, and they are created, but there have been no volcanoes, and there's very little earthquake activity that has been happening, which have been kind of originated from this area. So these are the two main things. I will stop sharing the screen. Okay. Do you hear me?
Yeah.
Yeah.
Okay. So main emphasis in this topic is about different plates, so we have got 7 major plates and some minor plates. Another thing that you need to know is, where is New Zealand located? So it's located at the boundary of the Pacific plate and Indo-Australian plate. And then those plates meet differently in North Island and South Island. That boundary is White Island, which is not too far from the Auckland area. It's in the North Island. There has been lots of volcanic activity. I think a couple of years ago, 2-3 years ago, there was a volcanic eruption, and quite many people, there were some fatalities over there. So the board, so those boundary of the plate is just a little bit off the land in the ocean, just, like in the North Island. So thing to remember is North Island has got volcanic activities. And why? Because one specific plate is sliding underneath, creating volcanoes and earthquakes. And South Island, both plates they're moving towards each other, but they're bulging upwards. So they move together and then they bulge upward. Whereas in the other one, they're sliding, the Indo-Australian. So this is Pacific plate is sliding underneath the Indo-Australian plate. It creates heaps of volcanic activity, but there's no volcanic activity. So the second thing that you have to remember, then you have to know there are three types of boundaries: convergent boundaries, divergent boundaries, and transform boundaries, and what happens in those boundaries. Okay. Today's lesson is about volcanoes, and most of the volcanoes, they are formed at the convergent boundaries. Okay. Divergent boundaries are mostly, they happen under the ocean. So there will be volcanic activity, but that's where the new seabed is formed, because the magma is coming out from the cracks between the plates. When the plates move apart, magma comes, kind of spews outwards. And where we are, New Zealand is, Pacific plate is going underneath. So the crust is going into the mantle. So this is called destructive boundary, convergent boundary, or destructive, because it is destroying the Earth's crust. And then transform boundaries, okay, where they just move sideways from side to side, like St. Andrews Fault, which is quite famous for. So today's lesson is about volcanoes, but it is quite straightforward. So I thought I will explain these three different types of boundaries and what is happening on the, where the New Zealand is located. Any questions, girls, about what I have explained so far?
No.
No, it's, yeah. So maybe when you will be doing the assignment toward the end of this week, you might need to go back onto the last week lessons, because most of the questions will be about plate tectonics. So the first part of this topic was about sedimentary rocks, igneous rocks, and the rock cycle. So you've done one assignment on that. So now there will be second assignment, which will be on plate tectonics. And mostly the questions will be asked in terms of the New Zealand geography. Okay. So if there are no more questions, girls, then we can end the meeting here, and that will give you some time to complete your today's lesson. But if there is anything that you're not sure, just send me an email. Any questions, girls?
No. Thank you.
Okay. So thanks for joining in. It's good to see you. You can turn on your. I've stopped recording now, so you can, if you like.